As a teenager, I really enjoyed unraveling complicated mathematical problems. I was curious to see what's happening behind the scene in some high-tech devices. I came to this conclusion that if I study electrical engineering, I will find a way to answer my questions. I joined Deakin in 2018 as a research assistant, but when COVID hit, I decided to continue my research as a second PhD in machine learning and AI. Deakin's direction in AI research is definitely aligned with my direction because the emphasis that they put on practical aspects of knowledge. They want their students to be able to apply the knowledge that they are learning into real-world problems.
The Deakin Business School mission is about being a catalyst for positive change and equipping our students to have an impact on society through the education we give them to make a real difference. What we're trying to achieve in that is to equip our students with education that can be applied. We want them to be exposed to the problems of the real world, where students, while they're studying with us, get an opportunity to work on actual problems in order to have the kind of skill sets that they can compete effectively in their careers moving forward. The EV challenge started off between our clients, United Energies and C4Net, with the problem that they're facing with electric vehicle detection in terms of the demand planning on the electricity grid. They approached us to say, can we formulate a competition whereby we could actually action a solution? In a nutshell, the challenge was actually quite simple. Can we accurately predict where an electric vehicle is being charged on the electricity grid from the smart meter data that's available through the providers? In electricity smart meter data, there's all sorts of things that draw energy, kettles, water pumps, power pumps, etc. And so to distinguish electric vehicles amongst all of those different signals is quite difficult, and that was the real essence of the challenge. So the competition was structured by 10 teams competing with each other to get the best solution for the client.
Our team proposed a predictive machine learning model that was capable of detecting almost accurately all EV profiles hidden in the data. Based on that model, we developed a system that was able to not only manage the load and optimize charging EVs, it also was able to minimize the error in the system. We came to this conclusion that instead of using a very complex mathematical model based on theory, why not we focus on what we see in real life? So we decided to see and observe how a typical person is using and charging their EVs. Yeah, and as a next iteration, I think we can elaborate on that project. We submitted the and keep working on that.
What we're finding here, it is a three-pronged approach whereby education, a problem and an application that matters for society inspires people to work together so hard on a challenge. And through a production like this, gave United Energy some solutions to inform their demand management of the electricity grid so that they know where electric vehicles are being charged so that they can sustain that kind of demand. I see it in the eyes of the teams that competed. They feel that they've made a difference. They've gained some experience, and importantly, they have had the fun of coming up with novel solutions and have that experience and belief and confidence in yourself that I can do that as a student. Business is evolving. We see technology developments coming into the world of business, analytics, artificial intelligence, and to equip students to work in this complex environment is part of what these challenges enable the university to do.
I thought probably at Deakin University, they are not only focusing on the quality of teaching, they also try to train the next generation in a way that they can have some more constructive impact in solving world's problems.